This is number 29 on page 117, and basically we have three blocks here that are on a frictionless surface. They're pulled with a 42 Newton force that acts on the 3 kilogram block, but then the 3 kilogram block has a string that ties to a 1 kilogram block that's pushing a 2 kilogram block. So one thing we have to get used to is seeing things as a whole and seeing things as a part. So the 42 Newton force pulls on this whole thing. And so if you read it, they want you to find A, the acceleration of the system, B, the tension in the cord connecting the 3 kilogram and 1 kilogram block, and C, the force exerted by the 1 kilogram block on the 2 kilogram block. Well, if I want to know the acceleration, that's the whole system. Well, that's one big giant system that's 6 kilograms. How'd I get that? I added those 3 blocks together. How much force is on those? There's no friction. So what's the net force? That is the net force. Well, we know that net force, the vector, equals A. That's a vector. Or if you look at your equation sheet, A equals F net over M. That's easy enough. That's 6 kilograms. Sorry, that is not 6 kilograms. It's 42 newtons. Back up here. That's 42 newtons divided by 6 kilograms. And that gives me 7 meters per second squared. That's the acceleration of the whole system. That's the acceleration of the 3 kilogram block. That's the acceleration of the 2 kilogram block. That's the acceleration of the 1 kilogram block, because they're all connected. That's A. The B part, we have to look at parts now. The B part, we got this string that we don't know the tension in, F sub T, and it's hooked to a system that is how big? 3 kilograms. In other words, if you look at the blue box and the brown box together, the string is pulling the 1 kilogram box, which is pushing the 2 kilogram block. So together, those two are 3 kilograms. Well, I already know the acceleration because I just figured that out. That's 7 meters per second squared. The tension force is the net force. And so Ft would equal F net, which would equal M, which is 3 kilograms, times A, which is 7 meters per second squared, and therefore Ft equals 21 newtons. Makes sense because only half of the mass is being pulled with an acceleration of 7 meters per second squared. Therefore, it's half of the 42 Newton force to pull those. And C asks for, we got to make it small now, not the whole system. We got a 1 kilogram block. I know it's bigger, but it's 1, and this one is actually a larger mass, 2 kilograms. And this 1 kilogram block is pushing. So if we looked at just the 2 kilogram, basically we have some force. We have the force, this force, and it's a net force. It's the only force on the 2 kilogram block. And how much, or how big is the acceleration? 7 meters per second squared. So therefore, F net, I don't know, from the 1 kilogram block equals 2 kilograms. Remember, M times A times 7. That's meters per second squared. That's 14 newtons. That makes sense because 2 kilograms is a third of the total mass of the system, and 14 is a third of 42. So there's different ways you can think about this, but F net equals MA. That's the big one we use over and over and over, and you have to go from whole system to smaller parts when you think about this one.